Warrior 11 Delta, descend and maintain 4,000.
2 Mike Mike, taxi to Alpha.
King Air 8 Tango Charlie, cleared for takeoff. 3-3 Golf, landable right turn.
How can so many aircraft operate this smoothly? Without the essential services of radar and air traffic control, the skies around most airports would be hopelessly clogged. This program introduces you to the common facilities found at controlled airports and explains how you, as a VFR pilot, can efficiently use the services they provide. We'll also expand on the communication skills needed to fly into and out of areas where an authorization from air traffic control is required. Let's begin with a look at transponders. Transponders are an integral part of the ATC radar beacon system. They enhance the identification of aircraft and help controllers provide better separation. The process begins when a radar antenna sends out a discrete interrogation signal. This triggers a reply from your transponder equipment. The reply is decoded and displayed on the controller's screen as a distinctive blip. The display of information on the screen depends on what you have set on your transponder. This knob turns your transponder on and off. When it is turned to the standby position, the unit is on, but it doesn't reply to interrogation signals. This position helps the transponder warm up before you need to use it. Sometimes the controller may ask you to select standby to reduce the clutter on the radar screen.
Cessna 241, squawk standby.
When you select on, the transponder begins to reply to interrogations from radar sites. This setting is sometimes referred to as the normal or Mode A setting. The altitude or Mode C setting is selected by turning the knob to ALT. If your aircraft has automatic altitude reporting equipment, your altitude will be displayed on the controller's screen. This light is called the reply monitor light. It flashes every time the transponder replies to an interrogation. It's a good indicator that the transponder is working. You can also test the transponder operation by pressing the test button. If the transponder is functioning properly, the reply light will light up. The ident button is used to help the controller identify your aircraft. When you press it, a signal is transmitted that causes your display to blossom on the radar screen. When you hear the controller say,
Cessna 241, ident.
Press and release the button. Never ident unless you receive a request from ATC. These windows are used to select the appropriate transponder code. Some codes are assigned by ATC, while others you select yourself. The codes and procedures for selecting them are covered in your textbook. Let's turn our attention now to the operating procedures at an airport with a control tower. We'll include some of the typical communications that occur during departure and arrival. The number of controllers varies from one tower to the next. Each person has a specific duty or position and, generally, controls one frequency. One of these positions is ground control. This person issues taxi instructions to aircraft moving to and from the active runway, as well as from one point to another on the ramp. Before you taxi from the parking area, you need to get an authorization from the ground controller. Most communications can be divided into just 4 basic elements.
Jeffco Ground, Cessna 52241 at the General Aviation Ramp, ready to taxi for takeoff.
The ground controller will tell you to taxi to the runway in use and provide you with existing wind information, the altimeter setting, and any pertinent remarks. At a busy airport, a tremendous frequency congestion would occur if the controller repeated this information to every pilot requesting a taxi clearance. To relieve this, many large airports have a specific frequency for recorded airport information, known as Automatic Terminal Information Service, or ATIS. Each time the recording is updated, it is given a new phonetic letter for identification.
Sutton Airport Information Delta, 1245 Zulu weather, temperature 85, dew point 47, wind 120 at 13, altimeter 3007. Landing and departing runways 17 left and 17 right. Advise the controller on initial contact you have information Delta.
Airports with a high volume of traffic may have a position called clearance delivery. It's primarily an IFR service, but can be used by VFR pilots to help improve the coordination of departing traffic. The controller provides you with a heading, altitude, transponder code, and departure control frequency to use after takeoff. If you want to use clearance delivery, contact the controller after listening to ATIS and before calling ground control. Inform the controller of your aircraft type, direction of flight, and that you have listened to the ATIS information.
Ashland clearance delivery, Warrior 81312, with Information Hotel, VFR northbound. Warrior 81312, after departure, fly runway heading, maintain 3000, squawk 4505. Departure frequency will be 124.6. Contact ground 121.9er.
When you contact ground control at an airport that does not have a clearance delivery but provides radar services to VFR pilots, you should include the direction of flight or your destination. In this situation, the ground controller will give you a transponder code and departure frequency.
Sudden ground, Cessna 62740 at the general aviation ramp, ready to taxi 17 left, VFR southeastbound with information Delta.
Cessna 740, taxi to runway 17 left. Departure frequency will be 119.3, squawk 1120.
With this clearance, you are authorized to cross all taxiways and runways on your way to 17 left. But it does not authorize you to cross or taxi onto the assigned takeoff runway. Once the pre-takeoff checklist is complete and you're ready to depart, taxi up to the holding line, switch from the ground control to the tower frequency, and let the tower controller know that you are ready to take off. Be sure to give your direction of flight or destination.
Sudden Tower, Cessna 62740, 17 left, ready for takeoff, VFR southeastbound.
If other airplanes are in the process of landing, the controller will advise you to hold short. This means that you are not authorized to taxi onto the runway and should remain at the holding line. When the final approach path is clear, the tower might ask you to taxi into position and hold. This authorizes you to taxi onto the runway and line up on the center line for takeoff. At the appropriate time, the tower controller will clear you for takeoff.
Cessna 740, runway 17 left, cleared for takeoff. Cessna 740.
When you receive a clearance with the word immediate in it, you should follow the instructions without delay.
Warrior 312, cleared for immediate takeoff.
Where radar is available, the controller may request that you contact departure control.
Cessna 740, contact departure control.
Because you are being handed off from the tower to departure control, the controller is expecting your transmission. Thus, your initial contact is very brief.
Sudden departure, Cessna 62740, climbing through 6,000 for 7,500. Cessna 740, ident.
The controller will let you know that he has identified your aircraft and will provide you with appropriate instructions.
Cessna 740, radar contact. Report reaching 7,500.
You are strongly encouraged to use VFR radar services when available because of the added safety provided. The level of service varies with the type of facility. Basic radar service provides participating VFR aircraft with traffic advisories and limited vectoring. The controller may help you spot traffic by letting you know its approximate location relative to your airplane. Other radar services, such as sequencing and separation, are used at busy airports to help controllers guide both IFR and VFR aircraft smoothly. When a controller issues a traffic advisory, it is given in relation to a 12-hour clock, with 12 o'clock aligned with your ground track. For example,
Cessna 740, traffic 1 o'clock, 2 miles. The Cessna 7500, eastbound.
if you are turned into the wind to maintain your ground track, the actual location of the traffic may be different than that given by the controller. In this example, the traffic is actually at your 2 o'clock position. When you're trying to locate the reported traffic, consider your ground track and encompass a wider range in your scan. Let the controller know whether or not you have spotted the traffic. If you don't see the traffic, tell the controller negative contact and continue to look. Keep in mind that traffic advisories do not relieve you of the responsibility of maintaining your normal scan for collision avoidance. When you leave the radar coverage area, the controller will let you know that the service is no longer being provided and will have you reset your transponder for VFR flight.
Cessna 740, radar service terminated. Resume your own navigation, squawk 1200.
Now let's turn our attention to some of the procedures and communications for an arrival at a controlled airport. If you're arriving at an airport with an operating control tower, it is a good practice to make your initial call-up approximately 15 miles from the airport. Before you enter Class D airspace, you must establish and maintain radio communications with the tower. A clearance from ATC is required before you enter Class B airspace. Your initial call-up should be outside of the Class B boundary and over a designated visual checkpoint. These points are shown on aeronautical charts and will be covered in depth in the section on charts. If you're approaching an airport in Class C airspace, you must establish two-way radio communications with ATC before entering the outer circle. You are strongly encouraged to make the initial call within the outer area. Let's take a closer look at the procedures for entering Class C airspace. Listen to the ATIS as you approach the 20-mile outer area.
Jensen Airport, information Sierra. 1445 Zulu weather, temperature 76, dew point 44, wind 160 at 1.
Plan your approach so that your initial contact with ATC can be made when you are above a designated visual checkpoint or prominent landmark.
Jensen approach, Cessna 62740, over Prospect Reservoir at 8,000 with Sierra, landing Jensen.
Cessna 740, stand by.
Since the controller used your call sign, radio communications have been established. This means you can continue on course and enter the Class C airspace. If the controller uses the words,
Aircraft calling Jensen approach, stand by.
radio communications have not been established, and you must remain clear of the Class C airspace. In most cases, the controller will give you a transponder code and ask you to ident.
Cessna 740, radar contact, 23 miles northeast of Jensen. Turn left, heading 220 for left base, runway 17.
As you near the airport, approach control will let you know when or where to contact the tower.
Cessna 740, 5 miles northeast of Jensen. Contact the tower 119.9er.
Cessna 740, tower on 119.9er. Jensen Tower, Cessna 62740, 5 miles northeast for left base runway 17.
At airports with an operating control tower, you must obtain a clearance to land.
Cessna 740, cleared to land, runway 17.
You may also receive additional instructions after landing.
Cessna 740, next available taxiway, contact ground, point 7.
Cessna 740, roger. Jensen ground, Cessna 62740, clear of 17 at Alpha 1, request clearance to general aviation ramp.
Cessna 740, taxi to general aviation ramp via Alpha.
As you gain experience, your knowledge and understanding of the ATC system will grow. You'll discover how easy it is to communicate effectively with air traffic controllers, and you'll learn to make efficient use of the services provided by ATC and radar.
Douglas traffic, Cessna 52241, taxiing to runway 28 at Douglas.
Colby traffic, Warrior 81312, taking off runway 17, departing to the southeast at Colby.
Denver Flight Watch, Cessna 52241, Hugo VOR, over.
Your radio allows you to communicate both with ground facilities and with other aircraft. Its proper use is important for smooth operations within the nation's airspace system. Although communicating by radio may be a new experience for you, you will quickly become familiar with the terminology and the format. After a brief look at some of the unique characteristics of radio communications, we will concentrate on some sample transmissions which relate to uncontrolled airports. A phonetic alphabet is used to reduce the confusion between letters that sound alike. For example, the letters E and P sound very similar, so the words echo and papa are used to represent these letters. 9 is the only number pronounced differently. It is said as niner. The key to good radio communications is to be prepared and brief. Most communications can be divided into just 4 basic elements. Identify the facility you are calling. Identify yourself. State the message or request. Conclude the transmission. Let's take a closer look at these elements. When you identify the facility, you may be speaking to someone who is operating a ground-based radio, or you could be addressing other pilots in the area. When you identify yourself, use the full registration number of the airplane. Precede this number with either the aircraft type, model, or manufacturer's name. You would identify this airplane as Cessna 52241. Sometimes a shortened version of the registration is used, but you should not shorten it yourself. Wait until the person you're talking to does it first. Your message or request lets others know your location and your intentions. To conclude your transmission, you may use the word over to indicate you are waiting for a response, or Roger to indicate you have understood the message. If the status of your communication is obvious, no conclusion is needed. Use these 4 elements to help organize your thoughts and decide what you're going to say. Write the message down if necessary, but be brief and to the point. When you're ready to talk, be sure the radio is properly tuned to the desired frequency, as discussed in the textbook. Then listen to be sure you won't interrupt another call. When the frequency is clear, hold the mic directly in front of your mouth and push the transmit button. Speak clearly and use a normal conversational tone. When you're finished, release the button and listen for a response. Let's turn our attention now to general radio procedures. At each uncontrolled airport, one specific frequency is used to communicate your intentions or to receive information. This frequency is called the Common Traffic Advisory Frequency, or CTAF. You should continuously monitor and use this frequency when operating to or from an uncontrolled airport. It is very important to remain alert and continue to scan for other aircraft, since they may not be radio equipped and some pilots might not use the frequency. There is no substitute for the see and avoid concept. By using the appropriate CTAF and applying good operating practices, you can enhance safety around uncontrolled airports. For example, during the approach, make your initial call approximately 10 miles from the airport. When you reach the traffic pattern, continue to announce your position by reporting downwind, base, final, and when you are clear of the runway. In a similar manner, when you depart an uncontrolled airport, announce your intentions before you begin to taxi and before you taxi onto the active runway. Let's look now at some examples of how to use the Common Traffic Advisory frequency. At an airport with no ground-based radio facilities, the CTAF will be multicom, and you will transmit on 122.9er. Since there are no ground facilities with this service, you will make your call to any aircraft operating in the area. Your initial call in this case is
Baker Traffic, Warrior 81312, 10 miles south, 4,500, landing Baker.
When you reach the airport, continue to announce your position in the traffic pattern.
Baker Traffic, Warrior 81312, entering left downwind, runway 29er, Baker. Baker Traffic, Warrior 81312, turning left base, runway 29er, Baker. Baker Traffic, Warrior 81312, turning final, runway 29er, Baker. Baker Traffic, Warrior 81312, clear of runway 29er, Baker.
When you depart an uncontrolled airport, the calls will be
Baker Traffic, Warrior 81312, taxiing to runway 29er, Baker. Baker Traffic, Warrior 81312, taking off on runway 29er, departing southwest, Baker.
At other airports, the Common Traffic Advisory frequency may be Unicom. This is a privately operated radio station that may provide wind and runway information. In this case, your initial call will go to the Unicom operator.
Mansfield Unicom, Cessna 52241, 10 miles east, descending through 6,000, landing Mansfield. Request wind and runway information for Mansfield. Over.
If there is an operator on duty, the typical reply will be
Cessna 241, Mansfield Unicom. Wind 110 at 5, favored runway is 09er.
The Unicom operator is not a controller. Therefore, you would continue to announce your position to Mansfield Traffic, just as in the previous example. Let's turn our attention now to communicating with a flight service station. An FSS provides a variety of services that you can access through your radio. Some of these include opening and closing a flight plan, weather updates, and at certain locations, airport advisories. When you communicate with an FSS, you normally precede the call with the word radio. A flight service station operates on a number of frequencies. Sometimes you can communicate and receive the reply on the same frequency. At other times, you may want to communicate on one frequency and receive on another, such as a VOR. During your initial call to an FSS, specify the frequency or facility you are listening to before you state your message or request.
Casper Radio, Warrior 81312, receiving Worland VOR, over.
At an airport with a non-automated flight service station and control tower, the FSS usually provides airport advisory service on a CTAF frequency of 123.6.
Scottsbluff Radio, Cessna 52241, ready to taxi, VFR westbound, request airport advisory.
Cessna 241, Scottsbluff Radio, wind 280 at 6, favored runway 30, altimeter 299er5. No reported traffic.
Talking on the radio is a skill that requires practice and a sound knowledge of basic radio communications procedures. As you gain experience and explore the variety of services that are available, you will find that your confidence as well as safety will increase.
When you plan a flight, it's essential you use the most current information available.
This program introduces the common reference sources used for flight planning and briefly explains how to interpret them. The sources we'll look at are the Federal Aviation Regulations, the Aeronautical Information Manual, Airport Facility Directory, Advisory Circulars, and Jeppesen Pilot Resource Services. Some of these publications give you very specific information, while others give general operational data. Let's begin with one which contains specific information, the Federal Aviation Regulations. A few of the areas you should be familiar with are Part 1, Definitions and Abbreviations. Part 61, Certification of Pilots and Flight Instructors. And Part 91, General Operating and Flight Rules. Due to the ongoing changes in the FARs, it's important that you have access to current editions and review them periodically. Another publication you should be familiar with is the Aeronautical Information Manual, or AIM. This publication is your official guide to basic flight information and ATC procedures. It covers a wide range of topics and helps keep you informed about operating in the national airspace system. Let's look at some of the items of particular interest to VFR pilots. The chapter on navigation aids describes in detail the various types of facilities that are available to both VFR and IFR pilots. For example, the section on VORs explains the frequency range of your VOR receiver and tells how to check its operation. If you plan on flying after sunset, you should be familiar with information in the chapter on aeronautical lighting. Things like specific airport and obstruction lighting are explained in detail. The different types of airport markings and signs are also covered. The chapter on airspace describes the various forms of controlled, uncontrolled, and special use airspace and their operational requirements. Since portions of this chapter are changed frequently, it's a good idea to review it periodically. The Air Traffic Control chapter contains a section on radio communications. It explains the terms and phrases used by pilots and controllers during ground and flight operations. Another section, entitled Airport Operations, explains the correct procedures for operating on or near an airport. The Emergency Procedures chapter contains valuable information regarding the authority and responsibility of the pilot in command, the services available from air traffic control, distress and urgency procedures, and rules governing two-way radio communications failure. The AIM also covers several medical facts that relate to pilots, such as the effects of alcohol, over-the-counter medication, high-altitude flight, and vision and illusions in flight. The Pilot Controller Glossary is an important supplement to the AIM. It provides definitions for most of the terms used in the ATC system. When everyone uses the same language, misunderstandings are minimized. Now let's look at the Airport Facility Directory. This publication contains facts about all public use airports, heliports, and seaplane bases. It is published in a number of volumes, with each one covering several states in a given region. To help explain the contents, let's look at some typical entries from the Southwest Directory. Each volume has a directory legend that helps you interpret the abundance of information. As you gain more experience in using the Airport Facility Directory, you'll find the entries easy to read. For example, here is the listing for Centennial Airport, which is one of several airports in the Denver area. We won't cover every entry in this listing, but we'll look at a few items that are pertinent to VFR operations. Centennial Airport is located 3 miles southeast of the city of Denver. This gives you a general area in which to look for the airport as you approach the city. The elevation of Centennial is 5,883 feet. This is useful for determining such things as the traffic pattern altitude, the upper dimension of the Class D airspace, and the accuracy of your altimeter. The letter B indicates that Centennial has a rotating beacon. This information can be very helpful when trying to locate the airport at night. These entries show the services which you can obtain at Centennial. S4 means major airframe and power plant repairs are available. If your airplane develops mechanical problems, you can get it fixed at this airport. The types of aviation fuel available are 100 low lead and Jet A. This information is important when you select an airport for a fuel stop. OX means oxygen, and the numbers refer to the types of recharging or replacement services available. Runway data are also covered in this section. In addition to basic dimensions and lighting, it includes specific information about each runway. Runway 17 right, for example, has a right-hand traffic pattern. This is a very important fact that helps you anticipate pattern entry instructions from the controller. Obstructions are also listed, such as the pole on the approach end of runway 35 left. The airport remarks section contains operational information about the status and usability of the airport. For example, there is a caution about waterfowl on and near the airport. As you approach or depart the airport, you should remain alert for bird activity. A bird strike can severely damage an airplane. Some of the additional remarks that relate to Centennial are that the airport is attended continuously. There are men and equipment working on Ramp A. And there are noise abatement procedures. The remaining sections of the directory listing for Centennial include weather data sources, communications information, and a listing of the various radio aids. Under the listing for the Denver VORTAC is a note to see the special notices. This section of the airport facility directory covers a wide variety of subjects that might affect your flight. Here is the entry referred to in the listing for the Denver VORTAC. The DME feature of the VORTAC may not be usable due to an overload of interrogations. This may influence your ability to use DME to locate Centennial Airport. A list of parachute jumping areas is included in another section of the airport facility directory. A section that should always be checked before a flight is the Aeronautical Chart Bulletin. It lists the changes that have occurred since the last printing of your aeronautical chart. Another method of supplying you with time-critical flight planning information is through the Notices to Airmen system, or NOTAMs. There are three basic types: NOTAM Ds, NOTAM Ls, and FDC NOTAMs. NOTAM Ds cover such items as inoperative nav aids, or runway closures at all public use airports. These NOTAMs are distributed from the National Communications Center. NOTAM Ls cover things like taxiway closures, ramp closures, and mowing operations, and are distributed only by local flight service stations. FDC NOTAMs are more likely to affect you when you get into more advanced flying. They usually amend instrument approach procedures and instrument charts. You can get NOTAM information from a flight service station, a computer briefing service, or the Notices to Airmen publication. Let's turn our attention now to another source of aviation information, the Advisory Circular, or AC. Advisory circulars contain information and procedures which are necessary for good operating practice, but which are non-binding unless they're incorporated into a regulation. ACs range in size from a single-page document to full textbook length and are issued as the need arises. They are numbered to correspond with the various FAR parts and subchapter titles. For example, the general subject number 60 pertains to airmen, and a specific number within the 60 series, such as 61, identifies subjects relating to the certification of pilots and flight instructors. One of these ACs, 6112 answers many of the questions you might have prior to or during your flight training. Knowing the general subject numbers will enable you to find ACs on a given topic much easier. A listing of all the ACs and their current status can be obtained from the Advisory Circular Checklist. Also included in this checklist is a listing of FAA publications sold by the Government Printing Office. A couple of these are the FAA Computerized Testing Supplements and the Practical Test Standards. You can order a free copy of the AC checklist from the address listed at the beginning of the AIM. Jeppesen Pilot Resource Services provide excellent reference sources. They combine many of the features found in the AIM and Airport Facility Directory into one publication. In addition, they include all of the pertinent FARs. The loose-leaf format allows you to easily insert revisions, which makes them some of the most current publications available. Let's take a look at some of the service features. Jeppesen Pilot Resource Services are divided into several subject areas. Common information is grouped together and identified by divider tabs for easy reference. For example, the section on air navigation radio aids presents detailed information about the types of navigational facilities available. A comprehensive GPS LORAN coordinate directory contains latitude and longitude coordinates for airports, nav aids, and waypoints. Airport locations include an FAA airport identifier, as well as the airport reference point coordinates. Another listing gives airports by the three-letter identifier. Navigation aid locations are also listed by name and identifier. Waypoint locations are listed by name. A unique feature of Pilot Resource Services is the FAR component. It provides the regulations pertinent to a wide variety of operations, including hazardous materials carried by aircraft and the National Transportation Safety Board regulations. Another very helpful component of Pilot Resource Services is the Airport Directory. It lists over 6,000 civil and military airports that are open to the public. In addition to the normal airport data, VFR entries contain an airport diagram to help you recognize the airport more easily from the air. Only the pertinent operational data is included for IFR airports, since detailed charts are available in Airway Manual Service. You might think of the airport directory as an airport facility directory with pictures. This program has provided a brief overview of the sources of flight information used during your pre-flight planning. It is your responsibility, as pilot in command, to familiarize yourself with every aspect of the flight and to ensure your planning is based on the most current information available.